All right. As I walked around the classroom, I saw a couple of you guys getting hung up on some similar areas, and I drew focus to this idea a couple weeks ago, but it's so valuable and so applicable to like almost every single model, it's worth revisiting again. If you looked at some of the reference images that I gave you guys, one of the handlebars had a nice little curve on it, right? A nice little curve. Now, what we don't want to do is try to have to build that curve by hand, right? Because what's it always going to look like? Garbage. It's always going to look really, really bad, because whenever we have to physically build something that's curved by hand, it's always going to look really faceted. It's not going to be. It's going to be an inconsistent curve. Okay. Whenever I start a new project, I always try to put my mind in the mindset of the person that would actually make the darn thing. So I always try to, in our case of the little bicycle, I try to imagine how a metal worker would make an object like the handlebars. Now, knowing what you know about the world, how would someone actually create like a handlebar like that? What material is underneath the grips of a handlebar? Metal, right? So what do they have to do? They have to bend it. They have to bend it somehow, right? And imagine that you're like one of those strong guys, not like me, and you like have a piece of metal in your hands, and you're like and you try to bend that thing. What's going to happen? It's going to bend at one point. It's going to go like this, right? Okay. It's not going to create that perfect curve. Now, in the metal shop world, what they do is they actually have a very specific and special machine whose sole focus is to bend pipe, along a defined radius, okay, to get a nice consistent curve, okay? Well, we want to do a very similar thing here in Moto. Let me just draw focus to a couple ideas that I hope you take some inspiration from. My handlebars are going to be circular, and I'll just create these. Let me just zip over here, and I'm going to create a 12-sided cylinder for my handlebars. And let me go into shaded mode here. Let's extrude this out a little bit. And this is just going to be a proof of concept. As always, we want to make sure that we're working around the origin of the scene. So don't forget, center selected, an incredibly powerful tool that will help us stay on the same page. I'm going to center that polygon around the z-axis. That way, maybe I can mirror this shape across the z-axis and have both sides of my handlebars ready to go. All right. Let me show you a really cool trick here. And this is something that I learned a long time ago in a galaxy far, far away. If you think about it, the top profile of our handlebars probably needs to look something a little bit like this, right? So the handlebars are going to come down. Of course, this would be where the seat of the bicycle is. Okay, there's the seat, the handlebars. Here's the middle, okay? There's a wheel over here and a wheel over here. Totally out of proportion, but you get the idea, right? Well, our handlebars, the ones with the curve, they need to change their direction all of a sudden, right? They need to change their direction and go back like that. So creating that bend in here is not a difficult thing, and there's a couple different ways that we can go about doing this. Let me show you a way that's incredibly controllable, because we're all about control in 3D graphics, right? We want to be able to define without any reasonable doubt how all these structures are placed together. So let me show you an old school trick that I've been doing forever. And I think I'm going to do this. I want to have my handlebars curve forward, and then they're going to bend back. Okay? Okay, so let's do this. I'm going to copy that polygon. So Command-C, so do Edit, Copy, and then on a new mesh item, I want to paste that bad boy in. And this is just a temporary placeholder, a way for us to extract that exact same, that polygon in the other mesh into its own dedicated environment. And here's what I'm going to do. I want to move it forward, and I'm also going to rotate it perfectly 90 degrees. Let's look at it from the top a little bit, and I'm going to just quickly match this up. And there are ways of being incredibly precise. Right now, I'm just going to see if I can do it quickly, and I'm also going to intentionally pull it that way and that way a little bit. All right. Let's return this polygon to the mesh it was in a minute ago by Edit, Cut, and then I'll return to my handlebars and paste that back in. So this is what we have. And now, if we select both of those polygons, we can bridge them to transition between these two different planes. Let's just do it real fast. Let's hit the bridge tool, and I'll click, and there we have it. Okay? Now, on the surface, you're like, okay, that's all right, I suppose, right? And it's okay. If we add some segments in here, now we can start creating a more like an elbow. Okay? Nice, consistent, controllable transition. I'm sorry, can you say that again? Nope. There's just a channel here called segments, which will automatically add new edge segments into the bridge tool. Yeah. There's a lot of them. Super smooth. Super smooth. Since this is going to be a subdivision surface object for me, like 3 or 4 is a good number to start with. All right, so drop the tool, and now we're free to continue working with this opening like any other polygon. If you wanted to add more segments. Now, why do you want to add more segments? I have no idea. Yeah. You'd probably want to determine the appropriate amount of segments at the bridge operation. Adding additional edge segments in here isn't going to increase the quality of the curve. It's only going to flatten certain areas when we hit that tab key. For example, if I go in and just loop slice this bad boy, not at a count of 30, okay, count of 1, see, it doesn't increase the curvature of that area. The bridge tool will increase the curvature and define that curve with those extra edge segments. So I hate to say it, yeah, undo is probably your guy in that particular situation, or initially put enough curves or initially put enough edge loops in that area to define the curve as to what you deem appropriate. And if you mess it up, it's no problem because we're working with straight polygons here. So if you mess it up, ain't no thing. You just always delete these. If you wanted more after the fact, don't necessarily have to hit undo. Just bridge them with edges now. Get the exact same thing and bridge, and then maybe add, a couple additional edge segments into the mix. Okay. So now it's time to create that curve for the handlebars. Okay. Let me show you a really, really cool technique, and I'm going to intentionally make it longer than it needs to be. Okay. And, yeah, somewhere right around there. We can always delete the extra unneeded geometry after the fact. But it's always important to start with enough, right? It's kind of along the same ideas that you can trim the excess later if you don't necessarily need it. It's be more difficult to add extra after the fact. And I'm going to loop slice this. And now I'm going to put a count to 30 because I want a whole bunch of segments in there, uniformly distributed. Because what we're going to do is that we're going to bend this pipe, similar to how a metal shop would bend a piece of pipe. Now, the quality of the curve that we're about to create is 100% dependent on how many edge loops are traveling from the left to the right there, which is why I just double down and I put 30 in there because I want a nice, consistent bend. Areas where there's a lot of curves really demand a lot of edge segments to define that curve. Now that we have a healthy amount of geometry, let's work with it. I'm going to filter the tool by a selection. Just going to select all this stuff. I'm holding the Shift key and the up arrow. And I'm going to stop it right about there because that's where I want my bend to begin. All right, let's look at this from an orthographic view from the front. And now we're going to fire off the bend tool, which can be found in the deformation series of tools. And it's right there. I love the bend tool. I find the bend tool just absolutely fantastic. I talked about this a couple weeks ago, but it's so good I'm going to talk about it again. Because the bend tool, well, for lack of a better word, it's just going to bend stuff. That's all it's going to do, okay? Where we click, however, initially is important. The first click is going to define where we want the bend to begin. So we have a little cross there, a little light blue cross, and that light blue cross is connected to that light blue square by a line. Okay. That light blue square on the opposite end represents the end of our bend. So we define the beginning and the end.
The ring is the beginning, right?
No, the light blue cross is the beginning, which is in the center of the ring. Now that light blue ring is really nothing more than a manipulator handle for the angle channel of the actual tool itself. And now, check it out. I can bend this thing.
So it would bend in the middle of that, right?
Say again? So there's my tool. Okay, now notice that I haven't dropped my tool because I just want to make a nice consistent 180-degree bend, but that's really not the result that I want. I'm not too excited about that. So while the tool is live, experiment around with the placement of that cross and that cube, and you're going to find you have a lot of control over how this object is going to be deformed. For example, maybe I want the start of my bend to happen a little bit more out here. So you have a little bit of a flat plateau before it starts changing. In addition, maybe I want to decrease the radius of my bend a little bit in the angle by messing around with this jobber. Okay? You can even go in if you wanted to create a more consistent kind of feeling here. Aha, there it is. That's not so bad. Okay? Now I can drop the tool. I've bent my pipe. And I have a very predictable, consistent curve all the way around the mesh. Now, all of these guys I don't necessarily need. So maybe I'll just chop them off, hit the delete key. There's my handlebars. Yes, ma'am? Uh-huh. I'm sorry, can you say that again? I didn't quite understand that. Uh-huh. Uh-huh. All right, well, let's look at some of the options here and see what we can see. So I'll fire off the bridge one more time. Now, I think I know what your problem is, Ms. Lopez. Your mode is probably set to linear, which is just going to produce a straight line. If you set it to curve, then it's going to push it out and make a curve. In addition, there's this tension percentage down here, which will pull it one way or another. So you can change the tangency of that curve based on that tension percentage. So lots of control. Lots of control. All right, now I have some pretty convincing handlebars made with just a couple clicks. Okay. And it subdivides quite nicely. Pretty great. Pretty great. Now, I saw a couple of you guys working on creating like the little grips for your handlebars. I thought that was really, really neat. And I wanted to draw focus to a really neat idea that's worth pointing out and reminding you guys about. Let me turn my wireframes back on. Okay. So I think I'm going to define that every second edge loop is going to represent one of my little grippy guys. Of course, we model with the overall form initially, but then we're always going to want to go in and edit that overall form to get the result that we're after. Okay, and I want to create the illusion of those little grips along the realm here, or along the line here. Well, as we know, if we subdivide this thing, it's going to turn into one cube, and if we add additional edge segments above and below the original, we can create tension in some very important areas. And let me show you an old school trick that will help you continue to craft all this. I'm going to bevel these edges out. And I'm going to use a round level of 1. And now you can see that at a round level of 1, it's keeping the original edge right where it was. And I've added 2 new edge segments around each of the loops I had selected a moment ago. Now I have a center line for each one of my little grippies. And I'm going to just select them real fast. I know it's like watching paint dry, so I apologize. Selecting things is never interesting to watch, but it's the most important part of our pipeline. Okay, there we go. And now I need to scale each one of these in a little bit, but they're all rotated and they're all at different angles, so I can't use the default action center. I want to do these all at the exact same time. If I hit the scale the scale tool and do that. That's clearly not what I want. I want each ring to kind of constrict locally on its own. So as a reminder, we talked about these last week, but our action centers are going to change the behavior of our tools. Changing our action center to maybe local will treat each one of these selected edge loops independently from the others. If I fire off the scale tool now, watch what happens. I'll get my tool handles down there, which is great. Now, each one of these is acting independently from the rest. Yeah, pretty neat, huh? There we go. Once I hit the tab key, we're on our way to creating a kind of a more believable grip structure for our object. I think the spacing, I didn't bevel these guys enough, but we're getting there, right? Within a couple clicks, we're in the realm of where we need to be. Okay, one other thing that I noticed that all of you, not all of you, but some of you guys were running into was working with radial array. I saw some of you guys struggling, and I wanted to spend a minute just kind of refreshing your memories as to how the radial array tool works. Our wheel is a perfect example of where we can strategically use that tool to get what we want. And here, let me do this. I didn't import my backdrop item. Let's add clip, load image, and I have, oh, you know what? The IT guys, maybe? Let's see. There we go. I have a secret folder on here. Please tell me I kept it. Thank you. If you haven't noticed already, I am horrible with lists. I do very poorly at reading lists quickly, so please bear with me as I struggle. Real quick, I want to change the transparency of my backdrop item to something quite high. That way I can see through the image to my mesh behind. Don't forget to do that. I saw a lot of you guys struggling with your backdrop item as it was occluding everything that was on the opposite side. Reduce the transparency, make it see-through, and you'll see the other mesh objects that are lying in wait behind. Okay. On an empty mesh item, I'm going to very quickly draw maybe one of these wheels. Okay. Now, there's a lot of symmetry going on in these wheels, as there are a lot of spokes. So this is a great place for us to talk just for a brief second about how all this is going to work. Let's create a wheel first. Here's another great little trick about wheels, and maybe I'll start off right around in there. I'm just eyeballing it here. There we go, something like that. If I hit the tab key, I'll get a better understanding of how this thing is going to look when I subdivide it. Things often shrink, okay? They often shrink when you hit the tab key. So there's a good shape, and now I can start crafting what I would like the wheel to be. Here's a power user trick for creating an object like the wheel, okay? Define the overall shape like that, and we don't need that center polygon anymore, so we can just delete it, okay? Now we have the structure of our wheel in place, and let me do this. Just going to move this out ever so slightly and extrude it. Actually, you can thicken. Thicken is an okay tool to use. I'm not sure in this particular situation if thicken is really going to be the best tool. I think bevel is going to be a better option for us. Yeah, bevel I think is going to be our guy. So there's my wheel. Awesome, looking okay. And now I'm just going to, in order to make it a complete wheel, let's just duplicate it. Mirror. Change my action center to origin. And there we go. Aha. And while we're here, let's define these planes a little bit more. Let's bevel out some edges because I want it to be, I don't know, kind of roundish. Let's increase the round level. So we're right around in there. Oops. Looks like I did my bevel a little too far. Excuse me. Let's try that again. There we go. there's a little bit of a crown on a lot of wheels and a lot of tires. So by having a flat section there geometrically gives us that crown, a little flat bit there. And I mean, it's tiny, but it's there. Okay, rock and roll. Things are looking good. Let's turn on our reference and continue to examine what we need to do on our little, on our little bicycle wheel here. So there's the actual tire itself. Now we have an interesting challenge in that we need to define the rim itself. So let's do this. Let's make our lives easier. We are working with a number of individual edge loops here. So what if we just simplify? I'm all about simplify, simplify, simplify. Sometimes it's better to take one step back in order to take two steps forward. So here's what I'm going to do, just to make my life a little bit easier. I want to delete those polygons. And then in edge mode, I want to fill that opening. I really haven't lost any information, but I've gained flexibility because now I can bevel both sides of my tire simultaneously, quickly. And that's what I'm all about, because now I need to define what would be the rim of the tire, of the wheel itself. Okay, so here's what I'm going to do. I'm just going to bevel, and I'm going to give it a little bit of an inset. There we go. That's pretty good. Now I'll do shift click, and now I'll do an inset here now. And I should do this to reference. That's pretty close. I'm happy with that. And then I'll do another shift click, do another shift in here, bring it down. Tiny movements go a long way. Yeah. And then at the end of the day, I can just simply grab that front and the back and bridge them together. Yoink. If I turn off my mesh item, there's my rim and my wheel, ready to rock and roll. With some additional sculpting in here, I can create a very compelling and interesting result. Maybe a small little edge bevel. There we go. Same with this one in here. Just round out that radius. A little too far, perhaps. And that looks pretty convincing as a tire for a bike. Yeah? Yeah, like hollow like that. Right. So here's what I did. Just made a cylinder or a circle. Okay. And if you want, you could extrude it out, make it into a three-dimensional circle. That's fine too. And then I was working on both sides simultaneously, and I just beveled to create the interior diameter, or the interior size of the wheel, and then I just bridged them. Boink, like that. Don't have to. Don't have to. You could delete it, but if you have both sides of the wheel selected and bridged it, it's just going to make an opening, a hole like you see there. I'm just full of good tricks, aren't I? Okay, so I'm happy with that. That wheel's looking really good. Let's just talk real second and refresh our memories as to how the radial array tool is going to work. You know, it looks like all my spokes are being arrayed around this little axle here in the center. So let's create that real fast. Again, just using a cylinder, nothing too fancy. I'll try to position it as best I can, just visually to the reference. Okay. Now, I like working in 2D here, so let me center select this to the Z-axis. Now it's inside my wheel. Okay. And now I know beyond any reasonable doubt that the axle, or part of the axle, is in line with the wheel. And now, let's see, it looks like it steps down a couple. So let's start beveling this out. Do that, and then I'm just looking at reference here. I'll do a shift click, and it looks like it, looks like it maybe does a slope in there. So let's do that. That's kind of fun. And then we're absolutely going to need to have a place for the frame to hang on to. Something like that. So right there, that's the little peg, if you will, that my these little arms will hang on to, and that's good enough. That really is. I'm happy with that. That's kind of fun. Now comes the interesting part of making all the individual spokes. Let's just make one, and I'm just going to do this by eye using a very small cylinder, 8-sided cylinder, nothing too fancy. And sometimes it's easy to start off with a big one and then center it and get it kind of flowing where we want it to be. It's clearly way too big. Let's change my action center. Let's turn it off. Let's make it teeny tiny. And now that I have a tiny cylinder, I can begin looking at how I want all of this to work together. All right, still way too big, so I'll scale it down along the X and the Z. And now we're marching closer to what I want my little guy to be. Now, I need to kind of eyeball it. I need to get that little spoke in the center of my axle as best I can. And one of the challenging things is kind of visually quickly understanding where the center of elements are, right? We're working away from the origin right now, but we can still be accurate to a certain degree, okay? Let me show you another old school trick that will help you visualize where the center of things are. And believe it or not, it's that polygon that's currently facing outside of our scene. This lovely feller, that one right there. And here's what I'm going to do. I'm going to turn my wireframe color back on. Here's what I'm going to do. I'm going to use edge slice. I'm basically going to slice that top polygon like this. And now I have a target. X marks the spot. Okay? Now I know beyond any reasonable doubt that right there, that vert represents the center of my axis. And now I have a target that my brain can click on when I fire off my radial array. I also now have a target for aligning my spoke to the wheel itself, because I can very clearly see, let's grab this one, and I'll move it, so that the center line of my spoke matches up with the center line of my axle. So I know beyond any reasonable doubt that I'm at least going to be somewhat close. Looks like I'm not quite where I need to be. Over here, we'll bury it up inside of my wheel, and it looks perfectly centered along the rim, so rock and roll there. Things are looking well. And before I go too much further, let me just duplicate this axle apart so at the very least it looks pretty awesome. Action center to origin around the z-axis. There's my axle. And now I'm ready to start doing my radial array. Okay, as a reminder, the radial array tool, found in our duplication series of tools, and it initially requires us to click to define the center point of the circle. So now that I have a target, I can get all up in there. I get super close. Boom, I just clicked on it. Whoops, hold on a sec. My action center was still set to origin. So let me go back in time. Let's turn that off. Now, when I fire off radial array, there we go. And that's pretty close. Okay? Very, very close. You can drop the tool. And if you wanted to, it looks like I had too many here. Yeah, that's good. I'm happy with that. I'm very happy with that. Now, one of the things that we could have done alternatively, instead of doing a polygonal clone, I could have done an instance clone, because there sure is a lot of extra detail that a spoke is going to have. I always try to examine transition points between different planes. Think mechanically on a lot of this stuff. If this was a spoke, it wouldn't just be stuck down in a piece of geometry, right? There needs to be some sort of transition, some sort of clasp that this little metal rod is going to be stuck into, both on the axle side and on the rim side itself. So maybe as an alternative, I cut that piece of geometry into its own mesh item. I'm going to paste it in here. There we go. And I'm going to do a magic trick here. This is whenever we work with items, the center point of the item is going to determine where it's duplicated from. I want to create a whole series of instances of my little guy here. And right now, if I was to fire off the move tool, see how my action handles are way over here? That's because the center point, which is really the determining factor of how an object moves inside of Modo, is positioned. It's positioned way off over there. Well, I want its center point to be where my geometry is. So here's a really neat power user trick. There's an option inside of the Edit pull-down menu that will change an item's center point quickly for you. So it's Edit, centered bounding box, and the bounding box is really just a representation of the total volume that this mesh item contains. In my case, it's just the cylinder. So let's do this center to bounding box center, and then boom, check it out. Now it's down over there. I would love it more like down here at the bottom. And then let's just do bottom. Yoink. Now we're where we need to be. Now, when we do our array, I can do an instance array. Instance radial array. Just make sure my action center's off. Good. Can clicky click. Yoink. Now it's doing it along the wrong axis. Let's do Z. There we go. I don't think I need 24 of these. Let's just start off with like 20. Yeah, that's a good number. All right. Now I have a tremendous amount of control over this, because I could very quickly go in and continue to edit this masterpiece of geometry and watch all of my other guys edit at the same time. Because now I can create quickly little transitions. Yeah, there we go. Maybe I don't really like that so much. Bevel it out. I'm going to chamfer it. That looks good. Very pleased with that. I can do the exact same thing up here on the top. Oops, grab the wrong button, excuse me. Grab that polygon, move it down, and now I can create some sort of funky detail in here. They'll give it a little bit more interest and believability as an object that is attached to something. I'll do a similar design. Or maybe I'll do a little stair step thing here. That'd be kind of fun. There we go. And I think these planes in here can be broken up quite quickly with a chamfer. And they all update simultaneously. It's very cool. It's very cool. Now I've made a global change to my entire design quickly within a couple mouse clicks without having to go in and touch each individual spoke. Okay, and mission accomplished. Questions about this idea? Pretty neat, huh? Looks like I perhaps clicked on the wrong point when I did my radial array, because it's I'm off center now, but that's okay. I can fix that. That's no big deal. All right. Fun stuff. All right, for this week, you have an interesting challenge in front of you for this week, as we're going to change gears a little bit. One of the exploding areas in the 3D industry is architectural visualization. I'd say one of my big primary goals for this class is to expose you guys to all the different outlets that are currently using 3D modeling for their work. We've talked a little bit about the entertainment industry. We've talked a little bit about the industrial design industry. We'll continue that conversation going forward. The medical industry, the legal industry are all using computer graphics and specifically 3D modeling in some really intelligent and creative ways. It makes perfect sense. There's a natural pairing between the architecture world and 3D modeling, right? It's a whole lot easier and definitely a whole lot cheaper to build a model of a building in 3D versus a scale model of it out here in the real world, right? It's a lot easier to make changes to a digital model than it is a practical model. And it's certainly a whole lot easier and cheaper to make a change to a prototype in the computer than an actual building itself, right? Huh? Since when? Yeah, moving a digital wall is a whole lot easier than moving an actual wall, right?
It's left click versus all your might and might.
You got it. There's no dust involved, right? Yeah. This industry is exploding right now. For a number of years, getting high-quality results were very expensive. Now, the software has matured to the point where the results are stunning. Photorealism is easy to capture these days in computer graphics. It doesn't take a tremendous amount of resources to get a good result. So there's the architectural world has just, jumped on 3D imagery to communicate their designs to their clients. At the end of the day, in the architectural world, our images are going to be used to showcase the design. However, the tool set in Modo can allow us to work pretty accurately. We can create CAD-level designs quickly in Modo using a number of tools that we're going to illustrate today. So there's no reason that you can't build an object inside of Modo and then have those plans and those renders and those drawings, if you will, be sent to a construction site and have that materialize into an actual thing. If you're careful and if you're detail focused on the measurements and the units that you're working with inside of Modo, you can do CAD level work. And CAD stands for what? Does anyone know what CAD means? You got it. Computer aided drafting, right? You can do CAD level type work very easily inside of Modo. So your job this week is to make a house. Any house. Don't care what house it is. However, I would make a small suggestion to have you do a house that you're very familiar with, like your own house. That way you're not having to figure out, okay, where's this wall go? What's the roof look like? You're already kind of up and running with the shape. You're very familiar with your own apartment complex or your own house or maybe a place that you've gone a lot. Shoot, you can even do this building. I don't care. Pick a house that you want to make, right? Does not matter. Someone last semester, or maybe it's even the semester before, he made the Simpsons house, which I thought was really kind of rad, okay? I thought it was awesome, okay? Very, very cool. You can make whatever house that you want, but you got to make a house, okay? Outside only, yes. Outside only. We're going to, the inside, completely different ball of wax. Yeah. The lawn, yes. That's going to come next week, though. We're going to focus all of our attention this week on purely building the geometry for our house.
If I know how to do grass, can you just do it this week?
No. Yeah. Yeah. I just want you to focus on the geometry. Just focus entirely on the geometry. And then next week, we'll jump into how we're going to texture and light and shade all this stuff to get the result that we're after. Okay? So this week, just geometry. Just geometry. Our homework is going to be the initial rough pass on our little house. So let's talk about how we can build houses and homes and any type of object quickly inside of Modo. Now, ideally, what we want to start with is a floor plan, right? It'd be great to be able to flush out the walls quickly inside of Modo. And luckily for us, there's a number of tools that will give us the accuracy and the speed that we need to get through this phase quickly. Okay? So let's take a look. We're going to extend the power of the pen tool a little bit. So I want to return to my basic tab. And you can find the pen tool in this button right here. There it is. There's a good old pen tool. And specifically, this is how the pen tool has always worked for us in the past. And excuse me for a second while I turn on my grid. There we go. And in the past, our pen tool has worked like this, where if we click within the frame, we're able to create a custom-shaped piece of geometry, an n-gon, a surface that's defined by many, 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 many points. Okay? A surface that's defined by many, many points. That's an n-gon. And this is an interesting start. Okay? This is pretty neat. But luckily for us, the guys down at Luxology, or excuse me, the Foundry now, have done an excellent job of thinking about how we can take the technology that we have here and apply it into the architectural world. They've come up with a mode that's pretty rad, and it's called the wall mode. Let me delete what I have here. I want to drop the tool and delete that crazy polygon. And once again, I'll return to the pen tool, but now I'm going to turn the wall mode to inner. Check out what happens, okay? Now when I click, of course, the first time I'm just going to get a single control vertice, but the second time I click, I get a cube, okay? I get a plane. The third time I click, check it out. Now I'm creating walls. If you analyze what the computer is doing for us, it's defining a width, and it's giving us these lovely miter joints at the corners. Yay! This is lovely. I like this very much, okay? Yeah?
If you hold shift or control, will it make them right angled?
We'll come back to that idea, but the answer to the question is no. I'll show you an alternative that's better than. Before we drop the tool, let's examine some of the features of the wall mode, because there are a couple here that are worth pointing out. Specifically, the offset value. If you're not getting any walls, that offset value is playing a factor here. What we're defining here is the width of our walls. The width of our walls, okay? And right now, my width is what is this? 0.5158 inches, okay? Inches. Now, if yours says millimeters, I can show you how to change your units here in a second, okay? But it's a defined width. In good old English units, this is equal to inches, okay? And this is equal to feet. So quote is equal to inches, and feet is defined by an apostrophe. Okay? If you see millimeters in there, you're lucky. I would prefer to work in millimeters, okay? But we can change our units inside of Modo pretty easily by going to the top of the screen, finding the dark word that says Modo, and opening up our global Modo preferences. You'll get this groovy little popover that has a number of different sections, but down here towards the bottom, in the input section, we have a category of channels under the unit section that we want to take a look at. And specifically, where we're going is the unit system. And you can see that mine is set to English, which is allowing me to work in feet and inches, okay? Yep, real easy. Now, on the PC, very, very different. I think it's under the edit menu. I really don't know. Your Modo preferences. I would suggest doing a Google search if you can't find it, because I honestly don't know. Where do you find system preferences? Does it say system, like a system menu? Yeah. And then into preferences. Okay, so I went into the units category down here under the input series of options. All right, so we have a whole series of units that we get to work with here in Modo. I've set mine to English, which is going to allow me to work in feet and inches. We can do standard imperial. We can do metric. We do game units, which are kind of unitless, or then there's actually unitless as well. So I wish nothing more that we could work in metric, but here in good old America, we got to work in English because we want to be backwards and weird from literally the rest of the planet. Okay, man, I just don't know why we have glommed on to these whole crazy ideas of feet and inches, man. Man, I mean, metric is so much better, right? Everything's just divisible by 10, right? Just move the decimal point. Bam, life is easy. Life is easy. Gah.
Well, you could just get on your boat and go on the other side.
I know, right? I'm going to Europe, dude. I'm going to Japan, where everything's a metric, dude. Gosh, because I'm so like sick and tired of trying to figure out, okay, what is 5/16? Is that like, how big is that in relationship to an inch? And why? It's like, no, let's just do everything's divisible by 10. Keep the math easy. I'm a simple-minded guy. Let's keep it all metric, yeah?
Probably best bet's to go to Canada because then you don't have to worry about NTSC or PAL formats for your TVs.
Yeah. All right. Well, point being, just choose a system of measurement that you want to work with. I'm going to keep us kind of in our common denominator, which is unfortunately English, okay? And this offset value becomes a really important player into the size of the object that we're working with. It's important that we start to define our model in scale as much as we can. It's really easy to figure out the distances, the spatial relationships of all the sub-pieces of our model if we already begin working with things at scale, right? I can very quickly see the size of that door and how big it is into the size of the window versus the comparison to that door over there. We can actually, heaven forbid, we actually measure something and have standard, kind of dimensions for some of these things. So working in real-world units is helpful. It really is. And I'm not an architect, so I don't remember off the top of my head, but my memory is saying that exterior walls are 10 inches. That's what my brain is saying. So now when I start to flesh things out, I know beyond any reasonable doubt that my walls are 10 inches in width, which is pretty cool. This is a live value, so if you wanted to make that offset value like 6 inches, for example, you can just go in and very quickly define that. offset. So this is a live channel. $10". Wait, why did I go back to 1 inch? There we go. So now that I know beyond any reasonable doubt that these are all 10 inches, I clearly have to spread some of this stuff out to get the illusion that I'm after, right? Because this would be the world's smallest room if they were in that current form. This is why working at scale is such important, because we can very quickly understand how all of these planes need to interact with each other to make a compelling shape. Before I drop the tool, let's analyze real fast the differences between the wall modes. I'm at the default, which is a wall mode of inner, and look where my control verts are in comparison to the wall, okay? The control vert, the little blue dot, is on the inside of the wall. If I change the wall mode to outer, boom, now the control vert is on the outside of the wall, which gives us other options on how we want to construct all this, so which is pretty cool. Okay, neat, fun. As one might imagine, both sides. Now it's going to do 10 inches from that point. Okay, so in every sense, my walls are now 20 inches in size versus 10. I'll be honest with you, I never use both. I've never used both. That's just me. Okay, I think I've almost always used inner. Yeah, but the options are there. Go crazy with them. I'm sure there's a reason for them being there. Okay, I'm happy with that. Life is good. Now, as Arthur pointed out, it would be fantastic if, if walls were straight, okay? Or if maybe we had some 90-degree corners inside of our home. Architects like that, 90 degrees, having everything be square, things like that are important for us in the architectural world. So let's explore how we can gain all of that type of accuracy inside of our system. I'm going to delete what I have, and I'm going to return to the top of my screen where we have a very, very important option. Our snapping engine. Now, our snapping engine is a global engine that's literally going to affect every single thing in the application. So the move tool is going to be affected. Any of our modeling tools, our animation tools, everything is going to be influenced by the awesomeness of the Moto snapping engine. Just be aware of that, okay? Now, it is a toggle. Right now, is it toggled on or off? Off, you got it. By simply clicking on that button or by hitting the F11 key, we can turn our snapping engine on. Pretty cool. Now, how do we control the snapping engine? We want to be able to rein in and determine what we are snapping to. Well, that comes into play in our tool options where we have this lovely, F11 brings open your snapping options. The X key is the toggle for your snapping. I spoke a moment ago. If you click on that button, you can see all of the different elements that we can snap to. And this is really, really kind of neat. As you gain in skill over the next couple of weeks, I hope you get a healthy appreciation for what the snapping engine allows us to snap to within inside of our computer. I've used a lot of different 3D modeling applications. I do a lot of stuff in Maya. I wish Maya would allow me to snap to these many things, okay? In other applications, you basically can snap to like the grid, okay? And you can snap to like other verts in the scene, but that's it. Look at all the different things that we can snap to. For us in particular, what's really kind of neat here is maybe doing a little bit of vertex snapping, and of course like world axis snap, straight lines, right angles. These are all important elements for us to work with as we begin flushing out the walls of our home. So let's do it real fast with my snap engine on and my wall mode set to inner. I can very quickly start to define what my house is going to be. Check it out. Boom. See how it snaps there? Yoink. Yoink. That's not me. That's the snapping engine going in and determining that this control vert is in the exact same location as the one below. If I continue defining it, can you see the little purple cube in that corner? What's that saying? That's a right angle. It's a 90 degree. This is the snapping engine coming in and helping me out a little bit here. Of course, this is all live, which is kind of cool. Now, it's also, can you see that right there in the corner? Can you see the little purple box? There's a little cross in it. It's saying, hey, if you put your cursor there, it's going to make a 90 degree angle. Okay? It's going to make a 90 degree angle here. This is a 90 degree angle. So it's going to help you out as much as it can. It allows us to very, very quickly go in and add a lot of geometry to flush out some really unique shapes in my home. Pretty cool. As a reminder, the snapping engine is a global engine. So make sure that when you're done with it, turn it off. Drop my tool, turn it off, I'm on my way. Yeah?
But can you just like switch to different modes, like the border and then extrude up?
Yeah, so now that we have the floor plan of my home, I can start building walls from this, right? It really is this easy. Let's look at my scene here. Now I'm going to be a good modeler, and I'm going to model this at the origin of my scene. So I'm going to center my mesh before I go any further. This will certainly help us when we want to craft a ridgeline and a roof for our object. Now, how are we going to create the height of our walls? Bevel's a good way of working. Who said bevel? Chris, get the gold star. Yeah. Mallory, too. Good job, guys. What's the other alternative for raising our walls? Extrude. It's important that we know the differences between bevel and extrude, because when we're doing this type of work, at times the differences are important. If I was to bevel up that shape, rock and roll, now I can actually do it to scale. Maybe I want all of my walls to be 8 feet tall. Boom. Now I know beyond any reasonable doubt that that each one of those walls is 10 feet tall. Okay, awesome. Yeah, so I just beveled it, and instead of just using the blue manipulator handle, I inserted 8 feet into that channel box. Yeah. Now, when we're, excuse me. Now, when we're working with the bevel tool, as a reminder, check it out. There's an opening down there at the bottom. It doesn't close the polygonal structure. This may come back to bite us here in a minute, right? I like to use extrude in situations like this. So if I need to do some loop slicing, I have that option available to us. It's easy to delete that bottom polygon if we don't need it later, right? But it's best to have it in case we need it. So I'm going to go back in time a couple steps. And instead of firing off my bevel, I'm going to do extrude and pull this value up along the y-axis to 8 feet. Drop the tool, and now I have a bottom and a top. All right, cool. So I have some walls here. Let's start making what would be, I don't know, maybe some windows and some doors, okay? Let's see here. I'm going to rotate my mesh. Let's see, like that, 90 degrees. Make sure we're... Huh? When you're working with the rotate tool, excuse me, I don't want to center it along the y-axis. I want to center it along the xz. There it goes. When you're working with the rotate tool, I would encourage you to hold down the control key before you grab the manipulator handle. That way it'll snap to 15-degree increments. The control key. All right. So here's my master plan. I want to have a door over here, and I want to flank my door with a whole series of windows. Because this is my house here. I love the sun. I want to see the outside. I want windows, like everywhere. Okay? And then I want to have an awesome little patio to barbecue, because I'm really into barbecue. Okay? I love hamburgers. They're awesome. Okay? If we look around the architectural world, there are some very consistent sizes and defined sizes for pretty much almost everything, right? If you go to Home Depot, there's like rows of doors at Home Depot, right? And they're all roughly the exact same height and the exact same width, okay? Yeah?
I can attest to this. I stock all kinds of stuff at HP Supply. Doors, it's like all 80 inches tall.
You got it.
It goes between like 30, 32, 34, 36.
Yep.
Like only 2-inch increments.
Yep. there are defined sizes out there in the architectural world, right? So we probably should start to mirror that kind of catalog of stuff in our model. It would probably be important that all of the windows be precisely the exact same size, right? It's an important detail. I can't have one window that's really skinny and then another window that's slightly off kilter. It's going to be noticeable in the final render. There needs to be uniformity along the the patterns that I create for the windows. So how am I going to add that geometry in? How am I going to physically create holes that are identical in size? Yeah, slicing is an interesting idea. Now, for our slicing, establishing the tops and the bottoms of our windows are really, really easy, right? Because I simply could just do that with an intelligent loop slice. Go mesh edit, loop slice. Let's do a count of 1 and a mode of free. And now I can go in and say, all right, maybe I want that to represent the top of my windows, okay? And I'll do another one, and that slice right there will represent the bottom of my windows. And I can very easily define that around the entire house, right? That's simple enough. But what about the vertical slices? A little bit more of a challenge, right? How in the world are we going to slice vertically with the exact same, in order to create the exact same width for all of my windows? Axis slice, I like the way you're thinking, but we're still not going to get the pattern that we're after. So let me introduce you guys a really neat feature. It's called Booleans, okay? Booleans. Booleans. Haha, punny for Halloween. I just got that, sorry. Yeah. Boom. Yeah. Booleans. Anyways, it's funnier in my mind. It really is. Okay. So Booleans are what we want to use, and this is a really neat structure. You see Booleans in a lot of other applications, and how each computer app decodes a Boolean is a little bit different. Here's my grand picture, and this is the way it makes sense in my mind. A Boolean is like a cookie cutter, and we're going to take this cookie cutter and punch some holes in my walls. Our cookie cutter is derived from another mesh object. So really we're going to take one piece of geometry and use that to slice another piece of geometry, like a cookie cutter, okay? So it's geometry slicing other geometry. Before we go any further, it's really, 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 really important that you are careful with Booleans, okay? This is one of those elements that if you start getting a little sloppy, if you're undisciplined, it's going to come back and bite you. It's going to really screw up your mesh very, very quickly. This kind of gets filed into, only you can prevent forest fires. Okay, you kind of need to know what you're doing before we start working with Booleans. So we're going to take it slowly. We'll look at it one step at a time, and we'll focus on the really important parameters that Booleans are going to need in order to do this cleanly and correctly. I'm going to delete my 2 edge loops here. Don't need them. And on a new mesh item, there we go. And let's actually start off by being really good stewards of our scenes. I want to name this one. This is my walls, okay? And mesh item number 2, this is going to be our cutter geometry. So this is our cookie cutter. And let's just put cookie cutter in there. Cookie cutter, okay? We physically need to separate the geometry into separate mesh items. The Modo Boolean system requires that the cutting geometry be on a separate mesh item for what we want to be cut. In our case, the walls. Okay, now we're free to go in and define the size of our windows however we want. I'm just simply going to use a cube. I could get real geeky with this with all the size parameters of our cubes. If I had Mr. Watermolen's experience in HD Supply, I could certainly craft a size of a window that matches an existing library window sizes. So I'm just going to, for lack of a better word, guess. Okay? I want to make something that looks pleasing to my eye, and that's definitely not. Okay, hold on a second. I'm not done yet. Maybe, yeah, something like that. Maybe I'll put 2 in there. And this is just as an illustration. Now, this is really important, and this is often where people screw up. the piece of geometry, our cookie cutter in every sense, needs to travel through the entire wall, okay? It needs to completely penetrate through our wall. So notice that it's going through my wall in its entirety, okay? Overshoot it. Be very confident that your geometry goes all the way through the walls, okay? The efficiency of the Boolean operation is entirely dependent on this being set. Okay. Now, let's actually fire off the Boolean operation. I'm going to go back to my walls, and notice that the background mesh object, or the unselected mesh object in the scene, has been shaded to that black wireframe. If you don't have your viewport set to this shading parameter, do so. It makes it very, very easy and helpful and easy to consume what's going to be working as a slicer, okay, or as a cutter. If you have more than one active mesh object in your scene, it's going to take everything that's unselected and use that to slice our geometry. So if you have like, if you're making a house and you have like a really cool model of a car that's sitting in your fictitious driveway and a model of a tree and a bush and a whole bunch of other stuff in your scene, anything that is visible potentially could slice your mesh, okay? You got to be disciplined. Only have the two mesh objects active. In my case, I have the walls, and then I have one additional mesh object active in my scene, which is called the cookie cutter mesh object, okay? Anything else will slice as well. It's going to take all of the background geometry and use that as a slicer. So with that said, let's run the Boolean. We can find our Boolean tools in the Geometry pull-down menu at the top of the screen. Geometry, and then towards the bottom here, you can see we have Boolean, and we actually have 3 separate Boolean tools. I'm going to focus all of my attention tonight on Solid Drill, which I find to be the most useful tool inside the Boolean suite of tools, okay? Because it gives us options. It gives us a lot of control, and it gives us the ability to choose what we want to do after our Boolean is complete. So let's fire off Solid Drill. You'll get a funny little popover, and there's 4 separate operations that we can ask the Solid Drill tool to complete. We want to choose Slice, because we want to slice our mesh. We want to slice our mesh with the background object. See how the driver mesh is set to background? This is what we want. So it's going to take all the elements that are unselected in our scene and use that to slice our walls. Let's hit OK. Done. Can you guys see what happened? If I deselect or make my cookie cutter inactive, check it out. It sliced both the inside of my walls and the outside of my walls with that cookie cutter geometry. Pretty neat, huh? Pretty neat. So if we take this one step further, let's do it one more time. I'm going back in time now. Hit undo. What we could do is maybe very quickly do a little copy paste, move it over there. And so there, I'm going to have 2 windows in the front of my house. Be a door over here. Maybe these guys, maybe this wall needs to have a whole series of windows. So I'll just copy paste, move the copy. I'll rotate it 90 degrees. There we go. Move it so that it penetrates the wall, goes through the inside and the outside. Now I want a whole bank of windows here. I'm just straight up duplicating geometry. I would like to have all my windows evenly spaced in a straight line. What duplication tool will allow me to do that? Clone, absolutely. Let's clone this bad boy. Duplicate, clone. Go. So maybe I have, there we go. That looks a little bit better. Aha, wonderful. Huzzah. Wonderful, I like that. Let me show you one fancy feature of clone. I want to copy paste just that one. Here's kind of a cool thing in clone that is really actually kind of neat. If you fire off clone, there's an option here called between. If it's on, watch out what happens. And I'm only going to do one copy initially. When between is on, we're basically defining the start and the end of our clone operator. And as we add more, they'll be evenly spaced and distributed in between the first and the last. There we go. And now, I'm a happy camper. To find the location for all of my windows, okay, maybe I need a big back porch window. Copy paste. And I'll make this one kind of big because I want to see my awesome barbecue in the backyard. So let's define what my back patio window is going to look like. Pretty big. Awesome. I can go return to my wall mesh, which is great, looking fantastic. And I can run the Boolean operation again. Geometry, Boolean, solid drill. I'm going to use the slice operation. Hit OK. Dun, da, da, da. I have all my windows. They're all the exact same width, and they're positioned perfectly vertically along my house. Nathan, and then I'll hit Dylan.
About the Boolean feature, does it only affect the one mesh underneath the one mesh that you're using, or does it affect all meshes?
It affects all meshes, and here's the dangerous thing, and let me illustrate this so everyone is on the same page. I've gone back in time 2 steps, so immediately before I fired off the Boolean operation, and I'm going to do this. I want to add a teapot on its own mesh item. And I want to make it kind of big. And I want to have a teapot window somewhere in my house. It's going to be like Who Framed Roger Rabbit, right? I have like a cartoon cutout that matches. It's way too big. There we go. Something like that. This is going to be awesome. Okay. Now, actually, you know what I should do? I should make this much, much larger. Well, it would still work, but you know, the spout is inside my wall. So you know what I'll do? I'll just do this. So I'll see the profile of the spout and the handle from the outside, but from the inside, I'll only see basically this back half of the sphere. It'll prove and illustrate the point. So that teapot is on its own separate mesh item, right? If I return to my walls and run the exact same Boolean operation again, solid drill, slice, turn off my cookie cutter, turn off my teapot, and you can see what it does. This is why you have to be very, very careful. Only have the mesh object that you want to slice your geometry with visible in your scene. Everything else needs to be turned off because you're going to get, you know, a teapot window in your home, for an example.
As in, like, using the eyeball, right?
Just using the eyeball. Just turn the visibility of that mesh item off. You're on your way. Yeah. Yep.
So, when you do that, can it create n-gon stuff?
Yeah, absolutely. Absolutely. This is a gigantic n-gon, as is that. I mean, it causes some problems. Let me go back in time a couple steps. I'll turn off my teapot. I'll do the Boolean one more time. Even though the teapot's still in my scene, it's not going to be evaluated when I do the Boolean because this visibility is off. So I'll do solid drill. Boom. Notice what wasn't sliced. The teapot's no longer there. And life is good. Yeah, and you can even, before we get to that, let me just mention real fast. You're going to get these little weird edges popping up every once in a while. That's okay. Let them be there. The computer is just trying to basically connect these new shapes with an existing edge, okay? That's fine. Leave it there. Don't delete it. You'll need these, okay? Leave them there, all right? Also, you have created a lot of n-gons, and if this was a professional job and I had a little bit more time, I would probably slice some of this up pretty quickly, okay? However, you can leave them as is. It's not going to render incorrectly. Out there in the professional world, you want to have quad geometry for everything. That way, you can send this model basically anywhere inside of our computer graphics industry, and it will work, it will deform, it will render, and it will be usable. For our project, though, you can leave the walls as gigantic n-gons. They'll render just fine. Modo completely supports n-gons, and they're an allowed surface type as long as the object is flat. Okay? All of our walls are flat. If this was a sphere and had a big n-gon in it, that is a bad thing, and that's going to render poorly. But flat, planar surfaces like exterior walls, we can hide an n-gon in there from time to time, and it's not going to be the most horrible thing on the face of the planet.
Like, I'm having a hard time visualizing
I'll let you visualize that on your own. I'll let you figure that out. Because there are some other fish that I want to fry tonight before we go home. Okay. Now the windows. Here's a really cool way to do windows. If you select the outside and then the inside, outside and the inside, outside and the inside, outside and the inside. Oops, inside. You now can bridge them all at the exact same time. Outside, inside, outside.
The next part
inside.
we actually be doing windows, like, complete with glass and trim and all.
Yeah. Try to add some of that in there as much as you can. Try to add that geometry in there. Part of your lab this week is to do some research on some of these details that you can add into your model.
Is there an easy way to do like blinds?
A blind, if you think about it, a Venetian blind is really nothing that literally is just a flat, skinny cube that's been cloned vertically about 200 times. Now, heed my warning, okay? At times, if you do something like this, this, and then if you were to select the inside going like that, the bridge may not work, okay? Let's see. Yeah, see how it went, I don't understand it. You have to direct it towards a sequence. You have to go outside and then select its partner on the inside. Outside and then select its partner on the inside. Outside, inside. Then bridge will work, okay? And I forgot my gigantic barbecue watching window. Wink. And there we go, okay? As you're going through the modeling of some of these extra details, like the casements and the trim, you want to make sure that you have geometry for the actual panes of glass. Next week, we're going to talk about the materials that we're going to apply to all of these elements to help us craft the illusion of something that's photorealistic. We're not going to make them transparent, because then we'd see the inside of our house, right? We do want to make them reflective, so we kind of creates the illusion of glass, okay? All right. One final thing. Let's talk about roofs. Roofs are an interesting little beast, okay? I want to illustrate this whole idea with a very, very simple roof. There are other ways to make roofs out there. If you use this technique and this sequence as the foundation for creating more complex roofs, it's not that bad. We almost always, when defining our roofs, want to initially craft the entire roof or capture the entire plane of the roof line in one mighty fell swoop. What shape is a roof? Yeah, they can be triangles, they can be pyramid shapes, but if you think about it, pretend that you're a construction worker. What is the shape of the material that you're creating a roof with? You got it. It's plywood. The underlayment of a roof is all plywood. Okay, and then they put shingles on top of that. Right? They have the plywood sheathing. They put some tar paper down, and then they put the roof shingles on. Is anyone a roofer out there? I spent an entire summer being a roofer, and I hated every single moment of it. It was a defining moment for me where I was like, nope, I'm not a roofer. This is not what I wanted to do, and I hated every moment of it. But I know a lot about how to make roofs now, okay? Yeah, repairing roofs, that was kind of my job. Anyways, so if we start with that idea initially, we can define the basic simple shape that we're going to start our roofs with. What basic simple shape are we going to start with? A square. Okay, a cube. And what I'm going to do very quickly is define the profile of my roof. Okay, so I'm going to grab a cube, and maybe I do this a little bit more dimensionally. That's 7 inches. That's a big roof, right? So maybe we'll do like 2 inches. Okay. Now there's some eaves and some other structures in there, so let's make it a little bit more beefy. 2 is a little bit. There we go. That's a little bit better. Okay, so we're going to define the pitch of our roof initially, okay? And I'm simply going to do this with the rotate tool. Now, I'm only trying to describe maybe half of the roof. That's all I'm going to do here. I'm just trying to get the left side, and then I'll slice and mirror to get the other side. All right, yeah, that's looking pretty good. Now, here we go, and I can see the origin of my x-axis by this line running down my scene, and I'm just looking at the pitch of the roof. That looks good. I'll use my slice tool, mesh, edit, slice, I'll hold down the control key to get a straight line, and boom, I'm just going to slice it vertically along my roof. Because what we need is a ridge line that looks like that. Perfectly straight line. I need all of those verts, however, to be precisely, and I mean precisely at the center of the x-axis, so I can mirror this geometry across the axis. Let's just do vertex. We'll set the position. There they are, set position. 0 along the x, and they barely move, but I have complete confidence that those verts are where I need them to be. Now look at my eaves over here. Man, that is humongous. You do not have an overhang like that on roofs at all, right? No roof has an overhang like that without some sort of post to hold up the weight of a roof. Roofs are actually very, very heavy. There's a lot of material sitting on the roofs, okay? So we need to bring our, that overhang back a little bit closer to the house. Every roof has a little bit of an overhang, but it's not as extreme like this. Yeah, a couple feet, somewhere right around there, okay? But how are we going to make this change? I can slice it, but I really need to have, this angle be 90 degrees. So I can't go in and just like, zoom, slice it like that, because now I have a structure that doesn't look like any roof that I've ever seen, right? Yes, I love it. I love it. Great job, Nate. Now, what people often try to do is that they do the logical thing and they simply move it. They move it closer, but if we move it according to the global orientation of the XYZ axis, we change the pitch of the roof. Boo, not good, okay? So life could be made a whole lot easier by, again, utilizing the powers of our action centers. If I change my action center to selection, the computer will analyze the slope of my selected geometry, and notice that my tool handles have rotated, and I have the x-axis that's shooting up the pitch of my roof. And I can just bring it in and get what I'm after. Mission accomplished. I love it. Let's turn off our action centers. I want to grab that chunk of geometry and mirror it. Duplicate, mirror. I want my action center to be returned to the origin so that it duplicates my geometry right here. Boink. Da-da-da. There it is. There's my roof. And then I can just extrude. Let me turn my action center off. Let's move it where I want it to go. Here's the beginning of my roof. I'll extrude it back. Create a little patio in the back because I want to have an awesome barbecue back there. All right, there's going to be the front door. Yeah, I got to have a door. However, what's kind of wrong with my house here? Well, don't worry about it not being connected. But we have the world's best natural air conditioning going on here. We got a gigantic hole, and I was like, we gotta close that gap in between the roof and the walls, right? Yeah. How in the world are we gonna do this, right? Well, if we take everything that we've learned tonight, perhaps we can use Booleans to help us out. Perhaps we can use the natural slope of the roof that we just created to slice our walls. Let's check it out. Here's what I'm going to do. I'm going to grab the loop of polygons that make the top of my house. Those guys right there. I'll hit the L key to loop it, and I'm going to bevel those up. And I'm going to go crazy, okay? Just going to go right through the top of the roof. All of this stuff at the top will eventually be deleted. Okay, I'm going to take my roof, and I'm going to simply cut it from the mesh that it's in, and I'll put it in my teapot mesh. Get rid of this. Get rid of these guys. And then I'll paste in my roof. There we go. Once again, I've divided them out, right? I've separated the element that I want to keep from the element that's going to be the cutting geometry, in my case, the roof, okay? Now I can return to my walls. I'll activate the visibility of my roof, and I'll run my Boolean. Geometry, Boolean, solid drill. Keep the operation to slice, using the background mesh as the driver, and yoink, there it is. Wonderful. Turn off the teapot temporarily, and all of this stuff, I'm just going to select the loop, hold, excuse me, there we go. I'll hit the shift and up arrow a couple times, and I'll delete my unneeded geometry. Now I can combine my roof with my walls, go. Life is good. Life is good. And now, it's a perfect match. 100% of this is live stream tonight, for sure. Power of Booleans, it's really, really kind of neat. Perhaps we wanted to have a more complex roof structure somewhere, okay? This was brought up in my Tuesday sections, like, well, what if you have like a different roof line that's going down this other direction here? As houses are often, or actually houses are very rarely one roof line, one kind of, triangle on top. Often they slope in a couple different directions, or if you have like an L-shaped house, you're going to have a roof line that goes in the opposite direction from what I've just crafted here. Well, use this idea of Booleans to heart. Check it out. Maybe I wanted to do some renovation and have, I don't know, a more awesome barbecue section over here. Okay? I'm going to copy my roof, copy it, paste it in. I'm going to rotate it 90 degrees. There we go. Now, let's do this. I'm just going to slice it right down the center because I don't care about all of this stuff over here. Okay? And I'm just going to do a Shift-H here. Delete all of this mumbo-jumbo. Don't need that. And I'll place all these border verts right where I want them to be. Perfect. Awesome. So there it is. Eee. Not so good, right? This is, if I saw this on my house, I would fire the contractor and insist on a refund, right? So that's not going to work, right? It's not going to work so hot. However, if we use the power of Booleans at our disposal, maybe perhaps we can get the result that we're after, okay? Let me show you what I'm talking about. Let's separate all this stuff out once again. I'm going to put this on its own mesh item. So I'll cut it, paste it on a teapot, okay? Now, I basically want to use this element, this roof, as a slicer for my other guy. That one, right there. So let's do it. I'm going to hide my walls so they don't influence anything here. And let's run the Boolean operation now. Geometry, Boolean, solid drill. We'll slice it. Now, I can delete all this stuff. And it'll be a perfect fit every time. Perfect fit. Dovetails just beautifully right into that wood. Now I can combine them. Over in here, unhide my mesh, compound roof. Made within just a couple mouse clicks. However, I probably should get rid of all of this jazz under here, right? So I probably shouldn't see that. To get rid of it, it'd be the exact same thing in reverse, right? Exact same thing in reverse. We're basically using both roof lines as Boolean slicers for each other to get the pattern that we're after. Pretty cool, huh? Pretty cool. Power of Booleans. But with great power comes great responsibility, okay? Be very mindful of how the Boolean slicing engine is getting to its final result. It's doing it from mesh objects, okay? And it's going to take any visible polygon as a driver for the slice, okay? So be very careful. Be very, very, very careful, please, okay? The folks in the design lab both love and hate when I drop Booleans on you guys, right? You often generate a lot of questions and a lot of problems with your meshes because of rogue pieces of geometry that you have forgotten are slicing other pieces of geometry when you're firing off the Boolean operation. So please be patient with the design lab staff, okay? They have an interesting challenge this week in managing all these small technical details that are produced. Questions, questions, questions. All right, let's chat for a second about your expectations for this week's homework assignment. As I mentioned a moment ago, what I would like you to do is to build a house, okay? Build your own house. Build any house that you want. However, I would suggest that you not build something extraordinarily complex like a mansion or something like that. However, if you want to do that, I'm not saying no, okay? But just, you have 7 days to build this, so rein in the expectations and the scope of your building, given the time frame that you have to complete this assignment, all right? So you're building a house. In addition, also build a small little landscape for your house, okay? Build a driveway, maybe some grass, a fence or two in there. Have fun with it. Build the house that you've always wanted to build. This is going to be a cool little assignment. And it's, again, an excellent, excellent portfolio piece. Okay? Excellent portfolio piece. Architectural modeling extends past the architectural industry. If you think about it, in every film that you've ever seen on the face of the planet, there's always been at least a building, right? Or something that looks like a building. Almost in every single video game that you've ever played, there has always been a building of some kind, right? So architectural modeling plays a much more important role than one might imagine inside the larger computer graphics industry. And in every sense, you're becoming an environment artist this week, okay? As we begin to craft this lovely, lovely shape. Okay. For your lab this week, small thing. I am forcing you to think a little bit more conceptually about your lab, okay? Or about this assignment. Your job for your lab is reference collection. I want you to go online, go on Google, and start looking at details. Start looking for blueprints, or for ideas. Start looking at the world of architectural modeling through a much finer lens. The details really are what help sell the realism of your object. I created a minute ago a box with a whole bunch of windows, but it still doesn't look like a house yet because we didn't add doors and windows and trim details and shingles and all this other stuff that will really help create a compelling result. We only find the details of these compelling geometric results in reference. So I would like you to do some research. Go find some images, be inspired by something, find some information that will help you craft the final result of your geometry for this assignment. When you're done, I would like you to zip up your little reference library. So all the images that you found, zip them up into an archive and submit that archive to the Dropbox on D2L. Unfortunately for us, the Dropbox doesn't accept a folder. So in order to get all of these files, all these images onto the Dropbox, you have to create an archive. It's really, really, really easy on the Mac to create an archive, a zipped archive of some files. If I zip over into the Finder, it really is this easy. I'm sure it's very easy, equally as easy for you folks on the PC side of things. But let's just pretend that this isn't the folder that I want to work with. If you right-click on it, compress GCOM 424, which is a folder. You click on it, it's just going to zip it up. It's not going to do anything to the original. As you can see, it creates a new file here that's completely, independent from the original. Really is that simple. Really is that simple. All right. Now, the reference that you collect, you're no way expected to build the stuff that you collect, okay? Be inspired by it. Use this as an opportunity to see the architectural elements that exist out there in our real world. There's not a limit to how many photographs or images you can submit. There's not a minimum. There's not a maximum, okay? So in every sense, this is a really easy lab assignment.
I don't know if I can handle this.
Yeah. This is like the easiest 25 points you will earn this semester. But I would like you to do it. Okay? Good 3D models begin and end with reference. I'm kind of old school in that fashion. Everything begins with reference. That's fine. Yeah, a building of some kind. A building of some kind. If you look at some of the samples that I've provided you with, I think one of them was like a Japanese thing of some kind. Yeah, that thing. I'm not sure what that is. So that will do. That will do. That's sufficient. All right. Questions on what we're going to be striving to accomplish over the next 7 days. As a reminder, geometry only. This is a two-part assignment. Geometry this week, texture, materials, and shading and lighting all next week. Okay?
So we did literally all the base material?
Yeah, it could all be gray. I mean, if you want to go in and set some simple materials to define different areas, I'm not going to say no to that, all right? But I don't want you to spend a whole lot of time, because we're going to talk about tiling textures next week and their role instead of architectural modeling, okay? One final administrative note before we all go home for this week, okay? Let's look ahead to the calendar just for a minute here. Bum, bum, bum. All right, here we are, end of the month. It's Halloween on Friday. Happy Halloween. Next week, Election day. Don't forget to vote next week. Don't forget to vote. Okay.
Will you write your name in, Pat Crandley, for
Pat Crandley for governor? Yeah, no, I'm kidding. That'd be awesome, but no. Please don't do that. Yeah. You'd vote for me? Sweet. I got one, right? I got one. No, but in all seriousness, please make sure you go out and vote this week. I know in a lot of cases these political elections seem meaningless, right? They're these really weird people. You don't even know them. You don't know what they really believe in. And oftentimes the effect and the results of our democratic system really aren't felt down here at the kind of in the trenches on the per human basis. However, I would encourage you to practice your civic duty, okay? It's we're part of a society here whose whole kind of raison d'etre, the whole reason for being is participation. So participate. Almost every single one of us in here is of age. Make sure you go out and vote. Even if it's for one thing, go out and vote. Specifically, look at those measures. The propositions that we're being asked to make some decisions on can have some pretty big lasting impacts on a lot of different levels within inside of our California culture. So go out and practice your civic duty. Do it. Get a little sticker that says, I voted. Some polling places give you cupcakes. It's awesome, right? I know. I went in, this was a couple years ago. I voted, they gave me a cupcake. I was like, whoa, can I do this again, right? Can I vote twice? Because I would love 2 cupcakes from you guys, right? I got a cup of coffee once. At the very least, go get a free cup of coffee, right? It's awesome. Go vote. It's a lot of fun. It's like, cookies? Right. I'm convinced that if free food was given out at every single polling place, there'd be like maximum participation across the United States. People will do the funniest things for free food and free t-shirts, which is crazy. You give someone a free t-shirt, it's like they won the lottery. It's like, you do know this t-shirt costs $2 at Walmart, right? But no, it was free. They got something for free, so it was worth it. No, I joke. I kid around. Yeah. Participate. I like to remind everyone this time of year that these elections, or at the very least, your participation in these elections are important to us. It brings focus to one of my favorite movies of all time, one of my favorite moments in one of my favorite movies, Star Wars Episode 1. You guys remember Star Wars Episode 1? Queen Amidala, the queen, the democratically elected queen of Naboo, and her planet was being invaded by the Trade Federation. You guys remember that part, right? Yeah. And then at the very beginning of the movie, yes, spoiler alert, right? At the very beginning of the movie, she had a great line that sums up my kind of belief about democracy. She says, the moment we stop practicing our democracy is the moment we lose it. So go out and vote. Go out and vote. It's a big... Yeah, go represent, right? This is your one chance to tell the world, to tell your community how you feel on an issue. You cannot complain about our government unless you participate in it, okay? All right, on that note, going forward, so there's some other important things. Don't forget to change your clocks this weekend, folks. Daylight savings, woo! We gained an hour of sleep! Yeah! Yes! You just ruined my night. Yeah, he will though, yeah. Now I get to wake up at 5 a.m. Woo! Awesome. Anyways, don't forget to change your clock backs. And really, where I'm going with this is I want to flip the calendar forward into November because there are some important things not coming up. Got Election Day next on the 4th, but on the 12th, this is important. I had to go out of town unexpectedly on some family business, so I will not be here on the 12th. However, you don't get the night off. We are still having class, okay? Except we're not going to be having class and holding class in this room. All of the content for that week's instruction is going to be found on D2L. So we're going to be doing it online that day. The curriculum for this class says that I can do portions of my class online. That week, all of the lecture is going to be encapsulated with a whole series of videos. You don't get a week off, okay? You don't get a week off. There's still going to be a homework assignment. There's still going to be a lab. I'm going to break it down into a whole series of small chunks and distribute the content online on the 12th of November. So you don't physically have to come into this room, but there will still be a graded homework assignment and expectations for you to meet during that week. So 2 weeks from now, right? On the 12th, which is basically 2 weeks from now. I will be gone on the 12th, and on the 13th, I'll return to my normally scheduled office hours and classes on Friday the 14th. Okay? Also, Veterans Day, campus is closed for Veterans Day on Tuesday. Okay, Tuesday, November 11th. Questions?
So, on the 12th, will there be some
Nope. Door will be locked. There won't be a warm-up. That'll be the only part that we won't have. Yeah. Yeah. Yeah, Mallory.
My question is about the assignment. So, did you want us having the mesh to smooth it out?
I wouldn't, yeah. On something like this, you probably don't need to make it a subdivision surface, okay? One other thing, which brings up a thought, keep in mind that the render camera is going to be some distance away from your object, right? You know, this is probably where your object is, or how your render is going to look at the end of the day, okay? If I go over to render here real fast, and I know this is the distance your camera is probably going to be, to your house, all right? If you can't see the detail from this angle, you can't see the detail from this angle. I had an individual a number of years ago spend a lot of time, and I mean a lot of time and energy on the front door of his house, right? It's a beautifully modeled front door, but then when he took a picture of it, the doorknob was just a circle. It was just a circle in the render. You couldn't see any of the lovely bevel profiles that he had created. The panels in the door were reduced into something very, very simple. Plan your model kind of from a render angle and a perspective like this, okay? I don't want you to put thousands of hours into something that you're fundamentally not going to see, okay? Questions? Other questions? I'll see you guys next week.